Check. Just yes. All right. Welcome everyone to the maybe final highlight of this SAT conference, the competition session with all of the results. We're gonna keep up the suspense as long as possible and force you all to stay all the way by doing the SAT competition last. Before that, I'll talk about the MaxSat competition, then the PV competition, and Arijit will talk about the model counting competition. All right, starting with MaxSat, mostly the same people organizing this year. We're very happy that Tobias Paxian from Freiburg could join us. He's been an immense help in many ways. Other than that, Matti, Ruben, Andreas, and myself. MaxSat, we've seen different ways of defining MaxSat, but for me and most of these solvers, it's a set of hard clauses that you need to satisfy and a linear objective that you want to minimize. Set up this year mostly the same as earlier. You have to be open source. You have to have a description. We will publish those descriptions. You have to also have a description for your benchmarks, which is nice because then you can maybe figure out what's going on. And this will appear at the evaluation website. I won't give a precise date, but hopefully as soon as possible. This year, we had a special focus on following the discussions from last year. We wanted to focus on the robustness of solvers. And here I want to acknowledge that Tobias did a lot of work here, and it was really nice. We had a regression suit that every solver had to pass in order to be able to participate. And the feedback I've heard of having such a suit has been very positive. We also provided an open source fuzzer, again, thanks to Tobias, which has at least increased the robustness and correctness of my solver. Also, as the first time for this year, we're banning the use of external closed source binaries. In particular, this means that Gurobi and Cplex are out, but Skip you can continue using. As a consequence, this year we unfortunately did not have a single implicit hitting set solver participating. If there's anyone who wants to work on an implicit hitting set solver with something like Skip, come talk to me, I'll help you get started. I think there's stuff to be done. We had 3 tracks, the exact track, where you're supposed to provide an optimal solution, an anytime track, where you're supposed to get as low-cost solution as possible in different timeouts, and an incremental track. Unfortunately, we only received benchmarks for the incremental track, no new solvers. So as such, we ran the solvers from a few years ago on this benchmark, because we really like benchmarks. We might perhaps like benchmarks more than solvers. Last time on the StarExec cluster for the exact track, anytime and incremental have been running in our cluster in Helsinki. Thanks to both of these instances for providing us resources. 1 hour for the exact track, 60 seconds or 5 minutes for the anytime track, and a bit more for the incremental track because you're supposed to do many optimization calls. Benchmark selection, again, same as before. We selected a random number randomly with a limit on how many benchmarks for every family. We ran the exact track, and then we looked at, well, which of those benchmarks were unsolvable by any of the solvers in 1 minute. And those ones we took as the anytime track. So the idea is to have more difficult instances. For the incremental showcase, we're calling it, we just took all of the benchmarks that the nice people sent us and run the solvers on that. Here are the people who sent us benchmarks. I'll admit I haven't looked into detail exactly what these are. I just want to say thank you very much. Without benchmarks, this evaluation would not run. As an indication of how thankful we are, you'll notice that there's a thank you on every single slide. In total, we ended up with 553 unweighted instances, 571 instances. We aimed for 600, and whichever ones we could detect had an optimum cost of 0, we removed, since for most of the solvers, an optimum cost of 0 is a contest between whose SAT solver is able to solve it the fastest. Anytime track 216 and 229. So then the results. Exact track. Quite a lot of solvers participating. As I said, no implicit hitting set this year. But as you can see, there's sort of a variety. Solvers are implementing different things using ILP as before, but you're also using pre-processing and also some local search in the exact track as well, which was nice to see. In total, if we count variants of these are the base solver names, and in total we had 15 different solvers participating, which I believe might be more than in the SAT contest. Marcus might. Then the results. Unweighted, we had 2 solvers that crashed on a few instances. These were the ones that also did the best. We have been in contact with the developers and provided them with very nice debugging instances. And as soon as they sort of find the issue, we'll remove this red from here. But for now, WMaxCDCL together with OpenWBO did the best with a slight asterisk risk, followed by UVRMaxAd, EvalMaxAd, and MaxCDCL. In the weighted track, it was core guided solvers all the way, cache with cache in the front, UVR, and then eval. This is sort of a more detailed plot showing that there's still some way to go in the unweighted track to catch up with the virtual best solver. So the different types of algorithms are contributing to this virtual best solver, which is nice to see. Here I'll also say that in addition to the crashes, we had few solvers that printed a model that was infeasible on the hard clauses. We have also been in contact with these authors. We only noticed this very late. So unfortunately, we told them they can check and fix their solvers, and then we'll remove the asterisk says on the web pages. In the exact track, there's not that much to do to catch up to the virtual best solver. Cache was doing really good. But as said, we're missing an implicit hitting set solver this year. So it might be that with that, we could push up the virtual best. Still work to do. Then we come to the anytime track. The idea is, I'll repeat this.
I don't know. Would it make sense to have a virtual best solver in that you would include an IHS solver just to see sort of, it would be interesting to see that curve. Am I making sense?
Yes, that makes sense. Of course, the current existing instantiation of an IHS approach are using libraries that currently are against the rules of the evaluation.
I know, but just as a like comparative curve for the potential and encouragement for, you know, solver authors.
That is true. Anytime track, we want to sort of find a solution as low cost as possible within a fixed timeout. As a metric here, we do our best for a fixed instance I. We do our best to figure out what the best known solution. We look at the exact solvers. If they happen to solve it to optimality, we look at the other anytime solvers. We look at previous years. And then we take that value and we divide it by the cost of the solution that your solver found. This results in a number between 0 and 1. 0 is bad, 1 is matches the best known cost. And then we average that score over all instances, and this is how we rank you. Mostly the same solvers as before. The prevailing approach here is to use a local search combined with some kind of a SAT-based approach, and then finalizing with, say, SAT-unsat search. These solvers are, I think, all of them complete in the sense that they will return you an optimal solution if given enough resources, but they're more tuned towards finding you a low-cost one fast. For downweighted, SPB MaxSat doing the best in the 60-second track, and actually the ranking is exactly the same for 5 minutes. The scores just get better. Here we can also see this is sort of the same kind of plot in terms of the score, and here there's actually quite a big difference between the solvers and the virtual best. So still stuff to do. Weighted track, same solver, slightly different variant first. Again, same ranking. So it's nice to see that the timeout doesn't influence the ranking in some sense. It just influences the quality of the solutions that everyone finds. Same thing. The virtual best of this is actually pretty good, matching the best known solution on most instances. Then for the incremental showcase, as said, no new solvers. Please make your MaxSat solver incremental, submitted it. There's lots of interesting research to do there. I don't think there's any papers on how to do core guided incremental. Well, we took the eval MaxSat and UBR that participated in the track a few years ago. On the new benchmark, I hear most of the instances were quite easy. You can see that only 2 out of the 72 took more than 20 seconds. And considering that this part 2 score is computed in terms of all runs, maybe you can figure out that the 2 were actually quite hard. So you spend 70 instances in under 20 seconds, 70 times 20, and then you sort of compare that to that number, 800 something. If somebody wants to rank solvers, eval did a bit better, but the idea is not sort of to rank them here. Maybe went a bit fast, but for any one of you who wants to take more time, maybe do actual data analysis on these results, we'll put them up on the web page. We'll also add these descriptions, source code, and hopefully all of the log files. All right, then one point we wanted to raise. MaxSat evaluation has been organized since 2006. In the beginning, it was Joseph, Chu Min, Felipe, and Jordi. In 2017, Fahim, Carlos, Matti, and Ruben took over, and now most of us have been doing it since approximately 2020, with Tobias being the newest one only this year. And there's been sort of an increasing voice heard among the organizers that some of them would like to step down, and I think, as you heard yesterday, Jakob might be a bit angry with me if I spend most of my time organizing the next year. So it would be very nice to get new organizers to, on the one hand, provide fresh perspectives. We heard StarExec is going away, where we will run it. Is there some kind of a track that anyone would like to have? Come talk to us. But also we want people who are actually gonna get sort of down and dirty and do the work. So where do we run it? Which benchmark should we have? Who should we pester for more benchmarks? Then actually running the tracks and summarizing. So come talk to us. At the moment, we're in a setting where it's unclear if we're going to be able to do this every year in case no one signs up. There's an email address. You can find that email address also on the webpage, or anytime you see any of us, come say hi. To end this part, I'll continue talking on the other competition, but for this part, thank you everyone who sent solvers, benchmarks. If you don't do that, we won't have anything to run. Thank you, StarExec. And thank you to our cluster people at Helsinki. Any questions on MaxSat?
What do you think about the feasibility of bringing proof logging to the MaxSat competition and having a certified track?
Do you want to organize it?
I'd be happy to provide a really, really good proof checker.
We've been talking a lot of proofs, and this is obviously where sort of MaxSat should be going as well. And then if there are people willing to get down and do it, I see no sort of fundamental reason why we couldn't have a certified track, for example, next year. But the current organizers will not do it. Come talk to us, and we can make it happen.
Yeah. So was there any specific benchmark family that posed the most problem? I mean, that was the harder one to.
Now I have to say I don't know. I haven't looked at the result that specifically yet. Often I run the anytime track, and often if you have large benchmarks, then time is spent already reading the benchmark. And Tobias told me there are some benchmarks on which Kissat is unable to find any feasible solutions within a minute. So these are sort of, if it's that hard for Kissat to even find any solutions, you can expect that the MaxSat solvers will struggle.
I realized that one more question. Although solvers have to be open source, I mean, do you have any sense of, suppose I just want to solve MaxSat problems and I don't care. So maybe I fire up, I don't know, Gurobi or EcoExpress or something like. Do you have any sense of how they would compare? And would it even be for future, would it make sense to, or possible to run them just to see the curves?
You're talking about a pure ILP solver versus, or what?
Yeah, the MIP solver, just run them, what would happen, right? Or skip or something, because they, I guess, for at least skip reads this format, I guess.
Tobias tells me he is planning to run skip on these benchmarks, and hopefully we'll have that on the webpage. He says he hadn't had the opportunity to do that yet. I'll give some intuition. There's a sort of shape you can find in the exact. This is not rigorous in any way, but where is this? Well, this shape is usually the solvers that also make use of a MIP solver. So they start with MIP, and then here this is sort of the timeout for the MIP, and then it pushes onwards. Last year, I believe Ruben checked that a pure MIP solver would land somewhere halfway in the rankings. So they can solve some things. Usually they can either solve the instances really fast or then not at all. So hence this trend of trying it for a while.
Because I mean, for marketing purposes, just publishing this. That's sort of a like strong, making a strong case for.
Yeah, sure. I agree.
Outside world.
Yes.
Oh yeah, sure. They are also in the sense of having possibly numerical issues. Yes.
Hopefully we'll have that number for the webpage results. If there's nothing more on MaxSat, could I ask someone to change the slides? I don't want to break anything. No, the first slide is fine. All right. PB competition. And here I want to start with making it very clear that I had barely anything to do with this competition. The only thing I'm doing, I'm standing here talking to you. All credit should go mainly to Olivier and then to the steering committee. Jakob can comment on how much they did, but Olivier has really been the workhorse here. This also means that if you have any difficult questions, I'll just tell you to email Olivier. I'll try my best, but I won't guarantee any answers. So the last PP competition was 2016. And this makes it very nice to do PP papers where you also always have to explain there hasn't been any. And apparently Jakob managed to make this happen, and Oliver had forgotten how much work it is to do a competition. The web page is already up. These slides are already there, and actually the slides were there already yesterday, but I didn't tell anyone. I had a steering committee. They did a lot of work in filtering sort of. This is the main part about this contest for me. You want to get a nice clean benchmark set, and here it took a lot of work to sort of categorize everything, get everything working, and get a nice set that hopefully we can use. There was separate tracks for certifying solvers, so proof logging solvers, and I believe that the way they did it was running everything together and then ranking certified solvers separately. There was also some work on clarifying the file format. The OPB format has its issues, and now we're sort of working on getting it more stringent, more usable. And now there's going to be sort of a restricted format that will help in the competitions. Solvers participating need to implement that, and then a more general format that can hopefully be used for many different things. And this is work still ongoing. 10 different teams, 13 submitters. I have to admit, I don't really know what the difference is. 15 solvers, 35 variants, which is really a lot. So there's definitely been an interest in this. And some bug fixes. We can probably talk, if someone wants to know, I can talk about some of these, but not every one of these solvers. But as you can see, there's a lot. And notably skip as the pure MIP approach, I believe. So what is pseudoboolean decisions and optimization? We have linear inequalities as the constraints. They also had a track on nonlinear constraints. And then you can, of course, have an objective. So decisions and optimization problems separately. So these are the tracks. Either you have so-called linear, so you combine the first two blue words with the second two blue words. So you might have linear decisions, no objective, only linear constraints. Non-linear optimizations, at least one non-linear constraint and an objective, etc., etc. The last part is a slightly different way of viewing instances where you separate hard and soft constraints. I think this is known also as WBO format. Yes, about the selection of instances, I want to acknowledge Johannes' work and our students' work. Our student did a thesis on a pseudoboolean approach and did a lot of work finding references for existing benchmarks, and then Johannes used that to make a very nice classification, which hopefully might end up in GBD at some point. There are some new benchmarks sent. Jakob doing the heavy lifting there. So these are the tracks. But apparently this non-linear stuff is still a bit difficult. So not enough instances to present a ranking, but the solvers can be found online. Thank you to Arnois for the computational resources. Ranking by the number of solved instances, and then average, so it's the same as the maxed evaluation. And then virtual best solver. All right, so for the decision problems, I believe the first place goes to a combination of a maxat solver and a pseudoboolean conflict-driven solver exact. A lot of solvers. Optimization, the first place here is actually my student solver. It runs skip for 5 minutes and then a core guided pseudoboolean solver after that. And apparently we're a bit surprised about this. That does better than pure skip. Four solvers participating in the certified track. And yeah, the fourth solver, Jakob, is a different version of exact. And now this is the sort of different view where you separate hard and soft constraints. So this means in terms of maxat, you have at least one hard constraint and all of your constraints are linear. Yeah, so contributions of the competition. We have an evaluation of the solvers in the same conditions. Oliver has worked a lot on it. We get the benchmarks. Hopefully we can have sort of more standardized testing in papers to come. Oliver did a lot of work debugging solvers as well, because when someone submitted a solver that didn't quite work, he actually contacted the authors and at least for our students helped them find out what the problem was. So that truly a tremendous effort. And apparently, according to Oliver, forced 3 new teams to implement proof logging in their solver, which I'm sure Jakob is happy about. As said, all of these details are on the web and specific questions should not be directed for me. Thank you. Thanks, Oliver, but thanks also to everyone who participated. And I'm fairly sure that if anyone is interested in running this contest as well, there would be help would be appreciated. I'll hand any questions on pseudoboolean. Good question. I'm sure it said somewhere. 1 hour.
Oh, but in terms of the input size, like is it bounded by some function, or can you?
The instances are different sizes. Yes.
But this time, is it?
No, it's 1 hour
1
for
hour
regardless of the benchmark. You get 1 hour,
Oh,
and
okay.
either you find depending on the track. I think here it was allowed to also give any time answers. So
Okay. So, is it? For each instance, you get 1 hour.
yes,
And what is the average size of an instance?
this I don't know. this,
Okay.
I'm not sure if Oliver computed this, but the benchmark will be available. So it is certainly computable, but I don't know.
Okay.
Yeah, so same question as Jakob had before. So like here skip is second, right, on this optimization rankings. Is it clear that so it looks like SAT technology is not catching up with OR technology, or is skip using SAT technology here? You don't know, right? Or
I don't know. They did a submission. Yes. All right, I'll hand over to Arjun for model counting.
Hi, good afternoon, everyone. So now I'll be presenting the results of this model counting competition. So this model counting competition has been there since 2020, and Johannes and Marcus has been organizing this since then. And this year I decided to assist them in organizing the whole process. So it is 3 of us. And for model counting competition, it has been model counting. It has been a great set till this year. For this year, like mostly starting the conference with references to model counting, then couple of papers, and finally the component casing paper winning the Stop Time Award. It has been a great year, and I'm happy to present the results. So the competition started in 2020 to make model counting more visible to different research communities. And the idea was to gather benchmarks and application instances from different domains. And let's check how we are doing in this 5th iteration of this competition. So in model counting, we have 4 different problems that we track with. So the first one is normal model counting, where the task is to count the number of satisfying assignment for a given Boolean formula. Second, we have weighted model counting, where for each of the formulas, there is this, for each of the literal, there is a given weight, and the model count is effectively the weight of all the models. The third track is the projected model counting, where with the formula, there is a projection set, and the task is to count the number of models projected on this set. And the fourth one is the projected weighted model counting, which is the combination of 2 and 3. So this year, we had another bonus track for weighted model counting, where we allow negative weights. So earlier, the weighted model counting used to be only positive weights. And this year, we had this set of applications on quantum circuit simulation from a group from Leiden. And for their instances, we needed these negative weights. So we decided to have this with bonus track for track 2 as well. So we have 5 tracks effectively this year. So yeah. Yes. So like, yeah. So
Even with negative, so you have negative weights of literals, is it?
yeah. So for each literal, the weight can be positive or negative.
If you have two negative weighted literals, the total weight becomes positive.
Yeah.
When they multiply.
Sorry?
No, so you have two literals with
Yeah.
negative weights.
Mm-hmm.
So the weight of the product will be positive, and
Yeah.
that is how you.
Oh, so in this track, like the weight for each, we have no constraint on the weights for any literal, so that like in this bonus track we can have the all weights as positive as well. So it is not restricted to negative weights. So it can be just negative or positive. So earlier we had the restriction that it can be only positive. Now we have no restriction on the weights at all.
But it's still literal weights.
Yeah.
The weights are on literals, and their product is the weight of the assignment.
Yeah. So definitions of model is still the same, that it is multiplication. The weight of a model is multiplication over all the literals in that model, and the weighted model count is sum of weights of all the models. Yeah. So yeah, so the way we measure is the number of instances solved by a solver. So the timeout is 1 hour, and we use star exec. We use a memory limit of 32 gigabytes, and there is no tie breaking while ranking the solvers. So if we have 2 solvers solving the same number of instances, they are ranked the same. And in case of ranking, we have 3 different rankings. So the first one is arbitrary precision, where the solvers are expected to return exact count for all the tracks. For the second ranking scheme, we allow small precision loss where we allow 0.1% relative error. So this is because we have this track because not all the solvers use this big number libraries so that it can be precise to the last bit. And we say some solver is disqualified if it has more than 20 instances outside this precision bound. We have the third ranking, rank C, where we have this approximate solving rank, where we allow a epsilon factor of 0.8, and we also say disqualified if we have more than 20 instances wrong. And for the evaluation procedure starts with an open call for benchmarks. So it comes around in September, and we ask for the community for the benchmarks. And we evaluate the solvers on this set of submitted instances as well as the instances that we have till now. So we select 200 instances for each of the track and divide it into a public and private track. First, we have the public instances published in StarExec, and the submitters are expected to submit their solvers to the public track and check the performance. And after the submission period is over, we have a private track in which we test the solvers on a set of public instances. And if we get some solver which solves some instances as wrongly, then we get back to the authors and ask them for a fix or get some feedback from them. And this year we had like around 4 solvers which had gone multiple rounds of feedback. So we have really helped them to bug fix their solvers. So this year we had like 10 different model counters submitted. So for model counting track, there are 10. Out of those, 7 were weighted model counters. For projected model counting, we had 5. For projected weighted model counting, we have 5 as well. And as we have many different type of solvers, as you probably know that there is the search-based or component caching-based solvers. And we have 4 solvers like that, 2 dynamic programming-based model counters, and then we have this approximate model counter, which uses hashing-based techniques. This year, for the first time, we had a portfolio-based model counter that is as per MOCO. So, and that was submitted for the first time, and we are having that counter, a portfolio solver for the first time. So for the benchmark selection procedure, we had all the set of benchmarks submitted, and we removed the instances which are very easy or which are unsatisfiable. And from each of the sets, with set of benchmarks that we have, we try to sample nearly equal number of instances from each of the sets. And we had a lots of different benchmarks were submitted for different tracks. So we thank all of the submitters for submitting this set of different benchmarks. Well, let's get back to the results. So first we have this model counting, the track 1. So like we have 100 instances. And for the second place, we have this, we got subset TD and subset TD-CH. Both the subset TD is by Tukka and Matti. So that was in the first place last year. And a derivative of that solver, that is subset TD-CH, both of them solved 48 instances. So those are together second and third places. And so for the first place, we have Ganak, that is by Mate, Jiong, Kuldeep, and Subham, and that solved 54 instances. So those are both for this rank 0 for exact counting and 0.1% error counting. And when we have this 0.8 epsilon factor, we have this combination of Ganak plus approximacy, that is again by Mate, Jiong, Kuldeep, and Subham, and that solved 63 instances. And here is the cactus plot, the CDF for the model counting instances. So as you can see that all these different component caching based comp-based techniques like Ganak, Sharpset TD, Exact MC, D4. They are pretty quite competitive in those instances, and they solve nearly similar in number of instances. In case of Ganak plus approximity, we get some improvement on a set of benchmarks. Interestingly, the portfolio solver that as per Moko that was submitted this year, has not helped that much. It is quite opposite to what we see in other cases, but that didn't help this much. For the second track, the weighted model counting track, we have in the third place D4 by Jomari and Pierre, and that solved 45 instances out of the 100 instances. And in this track, we really had huge weights, and probably the instances were very big. So for many of the instances, we couldn't count the weights exactly. So we do not rank anything for this exact weight. We start from this 0.1% error rating. So we have D4 for rank 3. Then we have Sharpset TD again for rank 2, and it solved 52 instances. For rank 1, we have Ganak, and that solved 63 instances. Here we have is the CDF for the weighted model counting instances, and as you can see, there is a significant gap between the solvers for different solvers. Now for track 3, again we have GPMC by Kenji Hashimoto, and that solved 35 instances. For the second place, we got D4, which solved 40 instances. For the first place, we have Ganak, that solved 48 instances. And these are all for this rank A and rank B, that exact and 0.1% error. And for 0.8 error bound, we have this Ganak plus approximity that solved 78 instances. So we see a big gap. So the exact model counters solved kind of nearly similar number of instances, like 48, 40, and 35. There is an improvement in case of when these approximate counters are also included in the list. For track 4, we have this projected model counting. In this case, the third position is again by GPMC, and that solved 64 instances. For second place, we have D4, and for that solved 72 instances. And for the first place, again, we have Ganak, that solved 75 instances. Now for the bonus track, when we have these negative weights, we have both in the second and third place as Sharpset TD and Sharpset TD CH, that solved 73 instances. And for the first place, we have Ganak, that solved 77 instances. So in this bonus track, there is the difference is pretty low, and the observation is if all the instances are either solved within 100,000 seconds, or it is almost never solved. And in this track, all the solvers perform pretty nearly similar, like DPMC, like the DPMC, GPMC, they solved 72 instances, Sharpset TD solved 73, Ganak solved 77. So the performance is pretty close. Well, so that's all about the results. To summarize, as Mate was talking in the model counting workshop, there is a lots of change in Ganak, and that was shown in this performance improvement for Ganak in all the tracks. For Sharpset TD, there was no change from last year, yet it is very competitive to Ganak. For DPMC and GPMC and D4, there is very perfect behavior, and they behave perfectly on all the tracks. As for Moko is the first portfolio counter that we got, although it solved no good performance, but it is interesting to have that in the competition. The combination of exact and approximate model counter that helped in projected model counting a lot. So that is again interesting observation this year. In this year, we have a new track that is motivated by the applications, and that is kind of we think as a success of this competition. And we have got a lots of new applications. So we thank everyone for being here. Specifically, we thank all the participants of this competition for submitting, for being patient in going through the feedback loops and being allowing us to be delaying in some cases. We thank all the contributors who submitted their instances. We thank our judge Martin Gebser and our technical advisor Daniel Lebre. And huge thanks to Aaron and Star Exec for allowing us to run our competition there. So the call for benchmarks for next year will be in September, and hope to see you next year. Thank you.
So I'm not sure I understand this counting of the number of solved solutions for Ganak, because it's kind of a probabilistic counter, right? And then if you have this one column where you say 0%, do I
Yeah.
get this right? So you're not running Ganak again, so you're just like taking out those instances which it solved wrong, or?
So 0.1% error is error on the count. So we didn't observe Ganak to be wrong on any of the instances. And like none of the solvers were, if it gets a rank in this 0% ranking, then it didn't count anything wrongly among our 100 instance set. So it was performing correctly on all the instances.
Yeah, but you had slides where sort of there was a difference when you switched to the like 0.8 or something. And so that part I didn't completely get how, yeah, here
Yeah.
for instance. Oh, this is only for the approx. Okay. So you're claiming the real Ganak there was never a hash collision. It always produced the correct result.
Yes.
Okay, thanks.
So Arijit,
Yeah.
I think this question was probably also asked in the workshop. I don't recall.
Yeah.
There's no proof logging here, right?
Oh, yeah, no, at this point, we do not have any proof logging implemented. So we are not exactly sure about the counts. We just believe the old counters to be correct, and that we have.
Yeah, so that brings up the next question. Did you see discrepancy in counts, or did solvers disagree on, did counters disagree on counts?
Yes, so we
And what do
observed,
you do in such cases?
right. So we had the pre-computed count that we had from the last year's solvers, and we believe those to be correct. And if we see,
Believe, I mean, do
Yeah.
we know?
so like as we have no proof logging at this moment, we are not sure that if we have the correct count or not. So like hypothetically, if all the solvers are wrong on one instance and it is wrongly produces a wrong count, same wrong count, then we have no way to say.
But otherwise, I mean, you did have
Otherwise,
cases
we
of
observe-
mismatch and then you took the majority or something. I'm just asking how
Yeah,
do you
so in
resolve
some- yeah.
differences?
So in some cases, we observed that there is some discrepancy among counters, but it was kind of evident that which counters were wrong, because let's say one of the counters were producing a different result than all the others.
That may be the right count.
Yeah, then we get back to the authors and they somehow corrected. And at the end, we had all the counts to be matching. So after the feedback and bug fixing.
So is there any plan to include?
Yeah,
proof
so
logging?
yeah, we definitely plan to include the proof logging in the next year, but we have to see how much we can go in terms of performance, because like as I understand that the proof logging model counters are not that efficient. So we have to see whether we get a correct count, like we proof log for all the instances we have.
So how do you pick the set of instances? You said they're contributed.
Yeah. So we have a set of, already we have a set of instances that we have collected since 2020 to 2024, 23.
Yeah.
And this year we also asked for benchmarks. So we had a large set of collection of instances. Now we pick 200 instances out of these all the sets,
Yeah.
and we try to pick almost equal number of instances from each of the set
Okay.
and make a count of 200.
Okay. And this original set of instances, was there any criterion? Like, how did you?
Oh,
pick
so
the-
we did a small filtering that if the instance is very easy, like
Yeah.
if it is solvable by 2006 SharpSat version
Yeah.
by within a minute, then we discard that instance.
Okay.
And if we have the instance unsatisfiable, then we discard that instance. Otherwise, we keep all the instances.
Okay. So it's based on how previous solvers perform.
No, we do not do anything like that.
No, you said.
So that is just a criteria to remove very easy instances.
Oh.
And that is like the SharpSat and 2006 version, a very old counter
Oh,
that solves an instance within 1 minute.
Okay.
So if there is no other question, then I will ask Marcus to come to present the SAT competition results. Thank you.
Okay, so welcome to the presentation of the results of another exciting edition of the International SAT competition. I'm presenting the results on behalf of the team of competition organizers. So yeah, so something on the history of the SAT competition, like the very first SAT competition already took place early in the 90s, in 1992. And there were 3 competitions, but then only starting 2002, we had yearly annual competitive events, among which there were 16 SAT competition, 5 SAT races, and 1 SAT challenge. The goal of the SAT competition is to promote SAT solvers and their development, the compilation of new sets of challenging benchmarks, and the evaluation and display of the current state of the art of SAT solvers. So the key rules in this year's competition, like as of last year, we have more proof checkers supported, and like this also supporting more proof systems. A key rule was that the unsatisfiability results had to be certified. And if the proof checker times out for the checking of the certificate, the instance counts as not solved. And buggy solvers would have been disqualified. I'll tell you more about this later. So if a solver would have produced an incorrect model or an incorrect proof, this would have led to a disqualification. So, okay, I did some foreshadowing. This was not the case in that competition, luckily. So that was nice. Okay, then, yeah, it was mandatory to submit solver descriptions, also benchmark descriptions. You will also find them online after the competition. I think, yeah, I will upload a lot of stuff tomorrow on the competition website. Then you will find like, yeah, also the proceedings where we always summarize or pack together the solver description and benchmark description. Okay. The ranking scheme was the penalized average runtime, and yeah, with a factor of 2, and which favors solvers that are faster. So there is some divergence. You will see it later in the plots as well. So that sometimes solver solved more instances, but another one was faster on average. We will see it in the plot. So, okay, so then we had this bring your own benchmark rule. So our community-driven approach to create challenging benchmark sets. So each participant was supposed to submit
20 interesting benchmarks, of which we selected most of the benchmarks. So here are some details on how we selected the benchmarks. I will also publish a script that you can basically also run to select the benchmarks, and you can look at the numbers, how we selected it. So we used 300 previously unused benchmarks, among which 195 were submitted this year. And then we also selected some unused submissions from the previous 2 years. And then we augmented that set by 100 random instances sampled from the anniversary track. Yeah, we had 33 configuration submissions. So that includes basically solvers and configurations thereof. Sometimes, so participants were allowed to support up to 4 configurations. Some teams used that, others didn't. So yeah, 14 solvers participated in the main track. Plus, this is an unusually high number. 7 participated only in the no limits track. Let's also discuss that later. So yeah, we had 8 solvers in the parallel track and 3 solvers in the cloud track. Okay, so these are the results of the cloud track. I may congratulate the winner of the 3rd place, the painless solver, painless PRS BVA to be exact, Masik Saudi and the others for the 3rd place. Then the 2nd place goes to PRS distributed by Yuhan Qian and the others. And the 1st place, congratulations to Dominik Schreiber for Malopsat for the best performance in the cloud track. Let's have a round of applause for the winners of this track. And please send us or send me your address. So there are some medals being prepared right now for you by Filuta. We will send them by post. Yeah, just send us an address. Okay, so this also holds for the other winners, which will come now next. Oh no, first have a look at the plot. So this is how the solvers perform. Let me just check quickly. Yeah, well, yeah, painless was 3rd. Yeah, so and it's actually solved more instances, but you can see basically that PRS was a lot faster. Right? We have no separate winners for SAT and unsat tracks in the cloud track, but just to show you that there is also some swap between the 2nd and 3rd place. Well, since we only have 3 participants, it wouldn't make sense to shuffle around medals across these tracks. So, but you can you might want to discuss with each other, like the winners of the 2nd and 3rd place. Like maybe you can merge the techniques. You might want to read each other's benchmark description, solver description. Yeah. Okay. So next, let's go to the parallel track. So we start with the performance on the satisfiable instance set. So here we have painless on the 1st place, Malopsat on the 2nd place, and PRS Parkis Inc. on the 3rd place. Let's have some applause for the winners of this track. And here the scores and the number of solved instances align. You can also see that in the track in the plot. Like yeah, well, it's a tight race in the end. Yeah. Yeah. Okay, let's continue with the answer. Okay, so here we also have painless on the 1st place. PRS Parkis Inc. is now on the 2nd place for the unsat instances, and we have Malop Imcheck by Dominik Schreiber on the 3rd place. Yeah, and here we have some divergence between the solvers. Like the par2 score of the second place is much better, but it solves one instance less. We will see it soon in the plot. But let's first raise some applause for these winners. Okay, and you can see in the plot that I've seen it before. But let's go back again. It was PRS and malloc imcheck. Okay, let's see. Yeah, so malloc imcheck solves more instances, but PRS, the red line, yeah, it's just much faster from the beginning, and then so right before the end, it gets surpassed by the other solver. Okay, so this justifies a bit the par2 score, right? So you have like a much better performance, and only then in the end a flip because of one instance more. Okay, so let's continue with the overall parallel track. So obviously Painless is on the first place. Then we have PRS Parkisat Inc. on the second place, and overall malloc imcheck by Dominik Schreiber on the third place. Okay, again some applause for the parallel winners, and yeah, now let's let's continue with the main track. So then we are finished quickly. So we have some amazing results here for Kissat, by Biere and all. They really dominate the main track by far with a new version of Kissat solver. Then on the second place, we have well, it's a SAT on the SAT subtrack. Sorry, I forgot to mention. Then we have on the second place in the SAT track Break ID by Bart Bogarts, Jakob Nordström, and the others. And we have HKIS BVA by Chinda and Jamengni on the third place. So yeah, let's some applause for them. Here you see the plot. Like Kissat is the new version of Kissat. You might start want to hack this solver. It's clearly above all scores. Okay, now let's go to Ansat. Same picture here. Kissat by Biere and all the others. First place. Then we have HCAT BVA by Jinder and Jamengni on the second place. And we have Kissat MAB DC by Jinjin Liu and the others on the third place. Okay, let's applaud them also. Like, and you might want to have a closer look when you download the slides from the website. Let's just now for the final round of results. You might already guess who got the first place in the main track. So the first place goes to Armin Biere and the others for Kissat SC 2024. Yeah, and then we have on the second place Kissat MABDC by Jinjin Liu and the others, and HKIS BVA by Jinda and Jamengni on the third place. Congratulations to the winners of the main track. Okay, so now that we know the results, you might be bored by the rest, but please stay a bit. There is some discussion. Yeah. So this time for the certificate, we had a verified checker for. So we used GRED in its SAT mode to check the certificates. So this is new. We used to use a very old Java implementation before that. This got replaced for this competition. Okay, and then for unsatisfiability, participants, as I already mentioned, could select between GRED, like using the DRED proof system, or DRED, DPR trim, or VeryPB. So There were no wrong certificates, so we found no buggy solvers. So apparently debugging for outputting a certificate really helps to raise the quality of solvers. So this is one exciting result also of this competition. So some could not be checked in time, and this year was the first year where we penalized the timeout also for proof checker timeouts, right? For the GRED, there were only 2 proof checker timeouts that which were basically on the same instance, which means probably this instance is hard to prove, right? And we had the DPR in the DPR category, or solvers who picked the DPR proof system. We had 17 proof checker timeouts distributed on 10 instances. And in the very PB category, we had 25 proof checker timeouts on 25 instances. And since there was only one solver participating there, this cost Break ID Kissert a lot of penalty in the unsat instances, right? So Break ID Kissert is super fast. We have seen it. They won the SAT track in the like the second place in the SAT of the main track. But basically, and the proof checker is now a lot faster than last year. So last year there were a lot more timeouts, so they really raised the mark. But still, it's they had these 25 proof checker timeouts. So there is still some work to do, but I am optimistic that this will also like be better in the future. Okay, so this is for the certificate. Then there are some issues like maybe you can answer that question later to me, because I would be interested why we had so many participants in the no limits track. So we had no winners in the no limits track because the main track participants were just faster, right? And so you have to be faster than a main track winner to win something in the no limits track. So this was not the case, and I checked. I also checked the certificates if they output some. So actually, they could have participated in the main track because the certificates were also correct, at least for those who output proofs, and also they did not hide their source code. So it's a bit strange, but maybe you can explain your motivation if any of these guys is here, why that is the case. Okay, then. We want to introduce new rules for benchmark submissions. So we realized that many submitted benchmarks are isomorphic. So there are a few guys submitting, like only 4 unique benchmarks of the isomorphic equivalence class, which is sort of not good because we don't want to create benchmark sets where you can just optimize for literal statistics-based lucky faces. And so this is one thing. So, but for this, to take that burden from you, we will provide an isomorphism checker for SAT instances. So you can check before you submit, right? Because this happens accidentally. So we know that. So this will be a new rule. And also, just a comment, because this happened in the past, please clarify the origin of the instances. If you are not the original creator of the benchmark instance, be kind and contact the author. They will probably be kind and allow submission, but you should at least mention them, and we want to reference them then also in the proceedings. Okay, and there will be in the future, you will also see this on the next slide, smaller timeouts for the parallel and cloud tracks. This is due to feedback from the engineers and scientists working at AWS. They did a great job in organizing the parallel and cloud tracks. We are also very thankful that they basically fund the parallel and cloud track by providing the resources, but they also put a lot of effort and work into this. So this slide is about the feedback we got from them. So in the future, we will reduce the timeouts of the cloud and parallel tracks to 200 in the 200 seconds in the cloud and 1000 seconds in the parallel track, because the results would be mostly unchanged, and moreover, like for most applications of stakeholders at AWS which use such solvers, these timeouts would actually already be way too long. So we want to optimize for fast solvers in this track in the future. And also it just costs a lot to use all these resources. Yeah, so then there was one complaint also, like the implementation and testing quality of the submission apparently has been very low. So they spent a lot of engineering effort in manually debugging the submissions and communicating with the authors. Also, only a small fraction of the submissions follows the specified interface of returning unknown if the solver is not able to find that or unsat. And so the wish is to, yeah, well, please clean up after you end your solver and don't leave any any intermediate state around in the container, because it corrupts the next job, and then the engineers would have to, yeah, manually clean up or restart containers, which just was a great burden in that competition. Okay. Then there is one comment which might be a hint. Solvers tend to perform best with only one solver per physical CPU core, right? Yeah.
They do not publish, though, how many physical cores there are on those machines.
Okay, so I just got the information. Okay, so
I basically
let me
perform a bisection over the years. What is the correct number of solvers to launch?
You run 64, right?
But with ImCheck, I run 56, and it actually performed better.
Yeah, because
so-
it's 32 physical cores plus 32 virtual cores,
I don't think
and so you overcommitted.
I don't think it's 32. Like just looking at the processor specification. So yeah, we should discuss this. They should publish
Let me
how
check
many
my mailbox
cores there are.
later with you.
Yes.
I can
Yes.
show you the comment of the Amazon engineer.
Yeah, I
So-
had the same comment. Last year I did the 32, and then because of I figured out it should be 64, I did 64 this year.
Yeah, in 2023, I submitted a 32 and a 64 core variant.
Okay.
And the 64 core one performed better. So 32 is too low. This year, 56 was better than 64, even though I did the proof checking at the same
Okay,
time.
so then we should maybe complain back that they should be more precise about the
Yes,
specific
please.
the machine specification. Okay, yeah. Okay, thanks for the comment. Yeah. Okay. So their reaction to this engineering effort spending in manually debugging submissions was to that they intend to add some automation for yes/no testing. So you submit and you will just get the feedback by an automated test where no, redo. So this will basically increase the burden on the submitters, but reduce the burden on the engineers and scientists at AWS. They don't intend to spend like workforce on improving the automation and debugging experience for submitters, but they would partner up with academic groups and students to work out a solution to get some informed feedback on why things went wrong at this. So this is a cloud infrastructure. So these things are running in the cloud. So yeah, just basically submitting a Docker container. And this is, yeah.
The thing is that the container is running all the time in between the instances as well. So it's being set up once, and then you need to clean up in between the runs of the individual instances.
Mm-hmm. Yeah. Okay. So this was like feedback from Amazon. Then, yeah, farewell star exec. Rest in peace. Yeah, we were like, we won't do a, how is that called in English? Schweigeminute. Be silent for a minute. No. But yeah, I just want to point out like what an important service Star Exec has been in the past 10 years. Like there were 16 automated reasoning communities hosted in that on Star Exec. It hosted over 60 competition the time it existed. Yeah, for 10 years funded by the NSF across 2 CRI grants. There were over 1,300 registered users, international users, right? So it was hosted in Iowa and but accessible internationally, used by the community. Yeah, some stats: 20 to 40 unique logins per week, 500,000 to several million solver invocations per week. So yeah, heavily used cluster, now dying off. And this was the last time such competition was hosted on StarExec, probably any competition hosted on StarExec. The cluster 4 and the form of it for coming competitions is still to be determined. If you want to participate or contribute, so we are actively discussing this with a few, like also in the organization team. So you might just drop us an email if you want to participate in this. We also discussed with Olaf that the association would support initiatives of creating a similar service. So yeah, if you have ideas or want to support us, just drop us a mail. Okay, so and we plan to next year have just an intermediate scale down edition in the spirit of a SAT race to just keep it going. But next year it will be just a bit smaller because we don't have StarExec and we have to do a lot of things manually, probably somewhere at some hosting institution. We still have to figure it out, but well, normally there are compute sources somewhere available. So, okay. So this is that. Then recognition and thanks, yeah, well, to the organizers and well, particularly also to the guys at Amazon who make the parallel and CloudTrack work, and then also to Aaron Stump, who for the last time was our contact for StarExec. Then also to Tomasz Bajo, who will create the medals for the winners, which are sponsored by Filuta. Here are some logos of the supporters. Thanks to the participants, and yeah, look up the rest on the website. Tomorrow, next week, so I will upload stuff, okay? We might have some questions, sorry. Okay, Jakob.
Yeah, I guess we discussed this before, but what's the checker timeout? And because it's, again, clearly very PB checking isn't as fast as the highly optimized DRAD trim and friends, but it's also doing much more powerful things. So it's a little bit, you know, it would have been interesting to see what the results would have been with, you know, just a little bit more time of proof checking, or maybe actually, you know, if all the checked proofs actually passed, or would we have a very different?
You will, yes, you will see. I will publish results without penalty. You will see that you could have made second place. Yeah. There is a timeout of 5,000 seconds in the main track, and a total timeout, like an overall timeout for the whole pipeline of 45,000 seconds.
So proof checking overhead worst case factor 8 for really hard.
Yes. Yeah. Dominic?
If we're at the topic of proofs, so the malloc imp check was actually running the on-the-fly LRAD checking next to it, which again checks every single clause and additionally confirms that with the use of signatures. I think it would be cool if we could like find some way to maybe with other proof experts to maybe get proofs to the parallel track or even the cloud track. I'm aware that this further complicates the pipeline at AWS, So it might not be easy, and we also need the technology for it. Like I discussed with Jakob a little bit earlier, but this I think would be really, really nice to get working sometime the next years.
Years, yeah, probably not the next year, but yes, yeah, good comment. So I think this is also important. Just also looking at what it, the benefit that it gives us in the main track, that we have like really stable, reliable solvers now. The other thing like about ImCheck is it's actually faster than the other solver. And this is basically due to the overcommitting, I think.
Yes,
right?
so the checkers actually use so little CPU time that it's still better to run 56 threads plus the checkers than 64 threads.
Yeah.
That's what I see from there.
This is how it basically came up, right? So there was this, you submitted 2 versions, and one which does additional proof checking, and the one with the additional proof checking was surprisingly faster. And now it came, so it basically boils down that the proof checking is a bit more lightweight on the virtual cores, which means that the burden of the overcommitting
substantially more lightweight because you
yeah.
launched 56 of the checkers at once. So
yeah. Okay, so are there more questions? Okay, I think then I can leave the stage. Thanks again to the participants.
Right. So all good things come to an end. So we are at the end of the 27th International Conference on Theory and Applications of Satisfiability. And I hope all of you had a great time. Before we conclude, I'd like to once again thank some of the key people who were involved in making this conference a success. First of all, of course, all of you for participating so actively. The program committee, which worked very hard to put up the strong technical program. R. Venkatesh, our general chair, for taking care of all the logistical arrangements. Our workshop chairs, Daniela Kaufman and Alexei Ignatiev. I think Alexei there. Alexei has left. The SAT-SMT school chairs, Kumar Madhukar, Priyanka Golia, Saurabh Joshi, and Ashutosh Gupta. The local organizing chair, once again, Ravindra Mehta, who's really led an amazing team to put all the arrangements together. And the amazing team itself, once again, I'd like to call out the names. If you're here, please stand up so we can acknowledge your contributions. Ame. Okay. So I guess all of us will miss your announcements. Anushri. Not here. Okay. And Diganto. Yes. Hemant. Hemant is probably not here. Okay. Kritika. Okay. Manoj. Yep. Nakshatra. Pranav. Sagar. Sahil. Sayantan. Okay. Vaibhavi. And all the student volunteers, if you're here, please stand up. I don't have all of your names. I'd like to acknowledge all the effort. Our finance chair, Rishikesh Karmarkar, who helped us sail through the, all the financial transactions. Kumar Madhukar, our sponsorship chair. Abhishek Shankaran, who put in a huge amount of effort to ensure that, the participation from the Indian students really. Kuldeep Meal, who's couldn't be present here, but he was a constant source of advice and guidance for us. Our webmasters, Weichie Wang and Anand Yolikar. Anand, is Anand here? Oh, okay. The SAT Association, Olaf has always been there to answer all kinds of questions we had. Stefan to help us with the financial matters. Our invited speakers, I think all of them have left, but nevertheless, I think we should thank all of them, Martina, Moshe, and Cesare. The SAT-SMT school tutorial presenters, Alex, thank you for coming. Frederick, I'm not sure if Frederick is here, and Armin, of course, thank you for coming. The award committee members, I guess only Jakob is present here. Jakob, where are you? Yes, okay. And of course, Daniel Laber, Shave Kai, and Nikolai Bjorner. And of course, for this wonderful facility that we enjoyed, for all the logistical arrangements, TCS Research, I think a very special thanks. I think we all owe a very special thank you to TCS Research. So and we also had other industry sponsors, Amazon Web Services, Cadence Design Systems, Synopsys, AMD, Google, and Microsoft. Dr. Anand Deshpande, who also helped us with a lot of advice and financial support. The Artificial Intelligence Journal, ACM India Council, Indian Association for Research in Computing Science, the Association for Logic in India, Easy Chair, Lipix, and I would also like to mention that there were a lot of other people like the drivers ferrying us back and forth from our hotels. They stayed back until late in the evenings whenever we asked them. Pardon me? You're going to mention them? Okay. Yeah, I mean, these people often go unnoticed, but I mean, they also put up a lot of effort for our convenience and comfort. So yeah, so maybe Venki, I'll ask you to say a few words about them.
Pratik has covered everyone. I would like to thank the AV operators, Aman and Nagaraj, for all the support that they provided throughout the conversation. I would like to thank Supratik, Olaf, and Roland for giving us the opportunity to host it and doing a great job of this whole server. And finally, I don't want to forget thanking the weather for having been perfectly timing its downpours. Yeah. So thanks, everyone.
Yeah, I believe we can't really end the conference without thanking Venkatesh, Supratik, and Roland again for what I believe has really been an outstanding conference. I mean, extraordinary in many aspects. The location, we've never been to India. We enjoyed it a lot, but also the organization. I mean, there's been such a great care going into this. Thank you very much indeed. It was really nice here, and we will be very happy to come again to India. Thank you.
Wishing all of you safe trip back to wherever you are going. Yeah, Dominic, you want to say something?
Sorry, I don't want to take the final word, but just thank you very much also to the competition organizers. I think that hasn't been
absolutely,
said
absolutely,
enough now.
Absolutely. Yeah, I'm sorry. That's bad. Thank you for. So have a safe trip back to wherever you're going. And since several of you are in India for the first time, please try to see around a little bit. Tourism, there'll be no pressure for attending the morning session invited talks. So enjoy your stay in India.